So I'm recording the Zoom's the Zoom session for AP review for the June 9th AP Calculus AB exam. Today is Wednesday, May 26th, and we're covering multiple choice non-calc, the Lavender packet, and we're looking at 1998, number 1, multiple choice non-calc again. So number 1, they're asking to find the x-coordinate of the point of inflection. So what you want to do here is simply just take the second derivative. So you do the first derivative, of course. You gotta crawl before you walk. So we gotta do the first derivative. So y prime is just x squared plus 10x. Then you do the second derivative, which of course is 2x plus 10, and you set this equal to 0. So you get x equals -5. Now, very important, you have to make sure that there's a sign change for the second derivative, which I know there is going to be. I know there will be one because, well, first of all, I don't know what choice we would have because this is linear. And, you know, yeah, it should change. The second derivative is positive here, negative here, so it's -5. But sometimes it might give you one that's a little tricky where one of the factors of the second derivative has a square next to it, meaning that there's no sign change. So you have to be mindful about that. So hopefully that one was pretty straightforward. Number 2, you guys should be able to handle. So this one's dealing with area. That's how I would actually approach this. Well, I mean, you have no choice because it's a weird piecewise function. So you just chop it up into recognizable shapes. So there's actually 5 shapes, 3 right triangles, 2 above and 1 below the x-axis, a rectangle above and a square below. So this is base of 1, height of 2. So that's an area of 1. This is base of 1, height of 2, so 2, 1. This right here is -0.5, it's below the x-axis. Base of 1, height's 1, 1/2 times base times height. This is also -1 because it's below the x-axis. Add all up, you get 1 plus 2 plus 1 is 4, minus 1.5, you get 2.5. Now, what if they ask for the absolute value of f of x? Then the negative areas become positive, and the answer would have been 5.5 instead. So 5.5 was kind of done as a trap, just so you know. That one you guys should be able to handle because we've done properties of definite integrals. Number 3 is kind of a part of FTC part 2, which we did talk about our last day of session 4 before we kind of just did nothing for the last couple days. And of course, you guys had your prank day on that Friday. That's x to the -2 power. That's 1 to 2 dx. So I would do that first, and then you add 1 to the exponent. So remember, when you have a power function, meaning that the base is x, the base is a variable, and the exponent is a constant, it's just x to the n plus 1 over n plus 1 divided by, divided by n plus 1, then plus c. Oh, good morning, Connor. Welcome for, well, thank you for joining us about that, and welcome to our session. Just so you know, we're going over, and we're recording right now. We're going over a 1998 multiple choice non-calc. So if you happen to have picked up those packets, the AP review materials from McGaney Locker 33 is where I placed them. It's a thick lavender packet. If you don't have that, that's fine. If you go to Schoology, you should still have access to the B period Schoology page because I know you're a part of that. And click on AP review materials. There should be a file that says multiple choice non-calc. Actually, I can even show you how to locate it. So in your case, you go to B period. And AP review materials. And multiple choice non-calc. We're also going to do multiple choice calculator later today. So we're on 1998. We just did 1 and 2. Again, record this, so if you want to watch that recording later, you may. So for this one right here, again, this is an application of fundamental theorem of calculus. So what we're doing is we're just simply doing the antiderivative. So in order to do that, I'm going to add 1 to the exponents, which is x to -1, divide by the exponent, which is -1. Don't worry about the plus c part because it's going to go away anyway for definite integral. I mean, if you put plus c, go ahead. But when I plug in 2, then plug in 1 and take the difference, the c's cancel, so it's kind of redundant to write it. So that's -1 over x, just so you know, we can clean it up. Plug in 2 and plug in 1, so it's -1/2 minus -1 over 1. So it's negative half plus 1, you get 1/2. So that's why the answer is C for that one. So I'd say those are pretty straightforward ones. Like, you kind of want to get to those quickly. We are going to encounter some that are a little more conceptual. And we'll kind of keep going in order here a little bit. And Connor, I know there's some topics you haven't quite seen yet. I'm guessing you haven't done some of the leftover topics. So I'll need to make sure that you have, I'll have to do some asynchronous stuff. And you're going to be in a different place than Will and Julia, because Will and Julia were in my D period class, and I covered, this is the devil in the details with this crazy schedule we had. So.
Oh, gotcha. Yeah. So I did like a little bit of it. Like the what's it called? Like the trapezoidal stuff, and the I think I saw like a little bit of the related rates, and like I'm sort of familiar with like the volume thing, but you know,
well, volume, maybe I'll have a separate set. Maybe next week I'll do a separate, because volume I had to kind of rush with my D period students last week. So I'll maybe next week would be a good time to do a separate session on volume and kind of look at those problems. What I'll do is the good news is that I did actually do a formal lesson of 5.4, 5.5, 5.6, which were related rates, optimization, linearization with my D period class, which I didn't do with your class. So I can send you all those items. That should be easy for me to do.
Oh, awesome. Thank you.
Yeah, so I'll send you like the videos and the worksheets and stuff like that. And then we could do practice problems with that next week. Yeah, because that would knock out half of the leftover topics. And if you, trapezoidal L'Hopital's rule is pretty easy. We'll just kind of integrate that into our, so maybe with today we'll do some stuff on that, which I didn't quite do with Will and Julia, but it's really easy stuff. And then volume we'll do. So that should take care of everything. Anyway, let's look at 4. So you told F is continuous and differentiable. So one thing that would really help you guys tremendously, maybe just to kind of do this daily, maybe, you know, when you're in the kitchen eating breakfast, or maybe you're, you know, if you exercise on a Peloton, I don't, we have a Peloton I haven't really used. I don't know, whatever you could do where you could, like, you know, have a piece of paper in front of you while you're doing something else, like eating or exercising. It'd be good to look at this cheat sheet. It's actually neon yellow if you picked up the AP review materials. And actually, I did add this to the Schoology page. Again, it's just called Stuff You Should Know Cold. And you can look at like a lot of the theorems. Like, for example, mean value theorem has a statement that if you're continuous and the first derivative exists, then this happens. Intermediate value theorem is just about continuity, as well as extreme value theorem and a closed interval. That, you know, that's what's going on, IVT or EVT. But MVT involves a assumption with continuity and differentiability. So the fact that they're telling us, hey, let's assume something's continuous and differentiable, what am I expecting to happen? I'm expecting the mean value theorem to be true. A mean value theorem, and plus our interval is closed. That is also closed. So first of all, I definitely expect MVT to be true, and that's MVT right there. Actually, right here. So that's actually true. We got to pick the one that's false. So I'm going to cross off A. A is true. That's a mean value theorem, just so you know, just tells us this, that if you have 2 points on a curve and you draw the secant line between them, as long as, say this is A and B, as long as everything's continuous differentiable between A and B, then there's going to be a tangent line with the same slope as the secant line. The secant line is red, the tangent line is blue. And the slope of the blue line, or the tangent line, is actually F prime. And this right here, this fraction is actually the red, the slope of the red line. So we're just saying those slopes are the same. And that's true, because we have those assumptions listed here. EVT will also apply, the extreme value theorem. So we are going to have, because you're continuous on a closed interval, so C and D are also out. Now, will the derivative have to equal 0 for some value between A and B? Again, these are out. Not necessarily. So your curve could look like this, or actually, let me draw a little better. Your curve could look something kind of like this. I do have a high and low point, but they happen to be my endpoints. I don't have to have a horizontal tangent. That's what this is telling me. I don't have to, I'm not forced to have a horizontal tangent between A and B. So that could be false. I could have one, but I don't have to have one. Now, will this exist? This is the integral. Of course that's going to exist. Of course, and that's part of FTC, the fundamental theorem of calculus. If you are differentiable and you're continuous, then you can find the area between the curve and the x-axis. There's no reason why you can't do that. And in fact, actually, if we go back to our notes, so this is a very nice conceptual question. And those will take a little longer to think through. The first three are more mechanical that we did. And remember, not remember, but you should be aware. This is another thing you want to look at too, national exam info. The first part of the test is multiple choice without a calculator, which we're doing right now. It's 30 questions, 60 minutes. You get 2 minutes per question. Some of those questions you're probably going to do in 10 to 20 seconds. Some you're going to do in probably, you might take 2 or 3 minutes. This one I think might take a little while. So you have to be just judicious about your time. But going back to FTC, let's look at the notes here. Lecture notes, where are we? Blank note. Filled out notes. No. Spring semester ago. I think I'm going to clean this up over the summer because it's driving me nuts here. 6.4. Fundamental theorem of calculus makes that assumption that yeah, if every continuous function is a derivative of some other function, and df or dx exists everywhere we know it's a differential function, and so the bottom line is that FTC will apply, meaning you can find the integral if you're differentiable and has a derivative. So yeah, that's gonna be fine. So again, I know a bit long-winded here, but the answer is totally going to be B for this one. B is one that has to be false, or sorry, could be false, because it doesn't have to be true necessarily. The other ones are going to be true, guaranteed, because of the continuity differentiability assumptions. So again, go ahead, Connor.
Oh, sorry. So just for C and D for the min and max, that's true because it's continuous, right? Like the differentiability does not.
Right.
Okay, cool.
That's why it's really good to know this cheat sheet here, the stuff you must know cold, which I added recently to the Schoology folder for AP review materials. And again, if you have the AP review materials you pick up from McGaney, and there's still plenty. If you haven't picked them up yet, there's plenty there. If you lost them, misplaced them, go back and get another one. That's totally fine. And there's a color-coded neon color packets. There's a table of contents that tells you what each one is. And this is a neon yellow stuff you must know cold. So if you happen to be on campus or you're going to drop your sibling off or something like that, just swing by the lockers, and it's a locker 32 or 33, I think, right by the trainer's room. Okay, let's keep moving here. For number 5, 5 is definitely an FTC style problem as well. So he's doing the antiderivative sign, which we should know is negative cosine. And again, this cheat sheet, again, is going to be your best friend. You have all the basic derivatives, and I believe all the integrals occur. It should be here. Be surprised. Yeah, here we are. Yeah, see, it's negative cosine. It says right there, negative cosine u. Cosine negative sine u du is negative cosine u plus c. So you're going to have negative, but it is a definite integral. So it's going to be negative cosine t plus c, but then you're going to plug in 0 and x. So you first plug in x, and the c is going to cancel anyway, so you don't really need it for it's usually for indefinite integrals. Without limits, you put a plus c. But for definite integrals, they're going to cancel anyway. So you get negative cosine x, replace t with x, minus negative cos 0. Okay? Cos 0, we should know, is 1. So negative cos x minus negative 1 becomes plus 1. So it's 1 minus cos x, and that's why t. Let's now give you guys a little bit of a push here. Let's talk about 6. 7 is going to be, yeah, go ahead.
Sorry, just to go back to that number 5. So the way that I've approached those problems before is like you used to like if you call x like u of x or f of x, like you just, instead of like doing the you know, like the line and then plugging in x and 0, you can just plug in like just the function at the top, and then it's like sine of x like plus the derivative or sine of the derivative, or excuse me, plus the derivative of like whatever the function is. And so it seems to have worked there.
Okay, you're confusing it with this. If I asked you that, then you would just replace the t with the x. I think that's what you're referring to.
Oh, yeah, maybe.
That was actually part of FTC, but this is a little different. This is just the integral straight up. If they ask for the derivative of the integral, they knock each other out. Then you replace the t with the upper limit, and you get that. I think you're conflating this with something else we did about a few months ago.
Okay.
Yeah, no, if that's what they asked, then the answer would have been totally A. And they put it as a trap because they think that people would pick that.
Right. Okay.
And this is just straight up. It's just straight up, just antiderivative.
I see.
And then just plug in 0 and x and take the difference.
Got it. Cool.
So this was FTC. What I just did was actually FTC part 2. So you're confusing FTC part 1, which is a derivative of an integral, which gets you back to the original function. You just replace the upper limit with replace your input variable with the upper limit. But this is FTC part 2, where you actually do the antiderivative and then you plug in. So
gotcha.
6 is going back to the fall, which is implicit differentiation. So if we look at that one, derivative, and what you could do is you could say, well, I'm doing the derivative both sides with respect to x, right? So d dx, cool. D dx, cool. So that's just an operator. So this is going to be 2x plus, and then you have xy, and then the derivative right side is 0 straight up, just a constant. You have x times y. So how am I going to deal with that? Well, it's a product rule. Derivative x is 1 times y. And then derivative y is also 1, but because you're doing it with respect to x, you have to say dy over dx. And that's what we're trying to isolate. So this is just straight up. So this should hopefully this jogs your memory a little bit. And I think what I'll probably ask you guys to do is after we're done today, maybe try one of the other multiple choice ones. Maybe I think there's 2003 comes after this one. Maybe try that one because you're going to see a lot of the same problems. Or perhaps do the mock exam. There's a mock final I gave. That might be actually even a better thing to do because then I can kind of see where you are right now and then what you need to work on over the next couple of weeks. So that might actually be a better thing to do. But so anyway, now I got to isolate dy over dx, and that's all algebra at this point. So 2x plus y plus x times dy over dx equals 0. You got to isolate the dy over dx. So the 2x plus y has got to go from left to right. Actually, you know what? Why even do that? You could, but let's be efficient here. You already told x equals, so just plug it in. 2 times 2. I don't know what y is, so hold on. Let's hold off on there. 2 times, and then you're trying to solve for dy over dx. So let's just be smart about this. Just plug in the 2 straight up. Why even try to isolate the variables here? Just make it easy for ourselves. However, what is y going to be when x is 2? Well, just plug 2 into the original equation. So that's 4 plus 2y equals 10. That's just very simple algebra. 2y equals 6, y equals 3. So I'm going to put a plus 3 here. Okay, cool. 4 plus 3 is 7 plus 2 times dy over dx. When you isolate dy over dx, you should get negative 7 halves. Because I got to move the 7 from left to right and then divide by 2. So this is very mechanical, a lot of moving parts, but it's very predictable. And it's not going to be as abstract as some of the ones you may see. I would probably argue that 8 is going to be a bit abstract for us. I'm looking at 8 right now. But questions about 6?
I just had a question. How much time do we get per problem for multiple choice?
2 minutes. But some you're gonna have to move faster than others. Like this one, I would say hopefully you can do it in 2 minutes. Might take a little longer. But like I would say like numbers 1, 2, and 3 that we did recently, you should probably do those in about 30 seconds. This is why you gotta practice, right? And you just do lots, and that's why I gave you guys just a crap load of practice. So you work on the pacing. And some are gonna slow you down a little. What you may want to do is maybe skip. Actually, you can't skip around because you guys are doing this in a digital format, and they've designed it in such a way where once you do a problem, once you submit, you've reached a point of no return. So you go on to the next problem. So yes, you are going to have to be, that's the one disadvantage of doing this at home and doing it online, is that I think they're doing this in a way to mitigate cheating. So yeah, so you won't have that luxury, actually. Have to be mindful about that. So just be mindful of you know, how much time you're spending. If it looks like something that's kind of like a very conceptual, not a mechanic, like you have to kind of know theorems or concepts, like number 4 or 8. It's okay if it's taking 2 or 3 minutes, because you are going to get those ones that are quicker. Now, something like this, if somehow you're making a careless mistake and you're not seeing where it is, you're like, dude, like I just don't know what's going on here. Then you're going to have to make a decision and just pick something and move on, because you don't want to run out of time. So I think that might be so the more I think about it now, I would want you guys to do a mock exam over the weekend and treat it like the real thing, where you're not gonna be able to go back. I'll see if maybe actually what I could do, because you guys have access to Albert IO. Let me actually. See when that expires also. I might need to email another person about. Yeah, because they actually have Albert IO, which I give you guys access to. That they actually do mock exams there too. And oh, cool, 34 days. Whew. Okay, yeah, I still saw some time. Yeah, because I could probably design it in such a way where you can't go back, so you can maybe practice doing it online. So maybe I'll do that instead. Let me think this through. Okay, let's talk about 7. Okay, now for 7, what I would do, I'll get a little creative here. So Connor would probably be a little more well-equipped for this one. Will and Julia are still learning about integrals, but I would actually, since you have a single term here, I would actually decompose this fraction like that. That's going to make your life much easier. And then I would simplify what's inside, which is x minus 1 over x. Now, for x, that's just x squared over 2. Remember, it's a power function. So you have 1 to the exponent divided by new exponent. For 1 over x, that's kind of a strange one. That's actually natural log of x, and it's actually absolute value. If you do write 1 over x is x to the negative 1 and follow that power rule, then you have x to the 0 over 0, which is obviously very strange. So it's a very special case, this one. It's actually natural log. And we're going from 1 to e. So you plug in e first, you get e squared over 2 minus natural log of e. And you got to know your logs. Natural log of e is actually 1 because ln has a base of e. And whenever the base and the input are the same, that's just 1. Like, for example, log base 2 of 2 is 1 because 2 equals 2 to the 1 power, right? So that's what's going on there, right? Anywho, minus, then you got to plug 1 in, which is 1/2 minus natural log of 1. Natural log of 1 is 0. And actually, I didn't really need the absolute value around e anyway because e is positive. So you have e squared over 2 minus 1, because natural log of e is 1, and then minus 1/2. And 1 minus half, negative 1 minus half is negative 3/2. That's why it's e. Okay, let's look at 8, and then I'm going to then give you guys a chance to do a little bit of practice on your own to see how it's going. For 8, let f and g be differential functions of the following properties. Okay, so what this tells me is that this is an increasing function the entire time. And then we have just that. Okay. Actually, no, I lied. I don't know if it's an increasing function the entire time. Hold on. All I really know is that it's just y is just g is positive for all x. That's all that tells me. Okay. So let's work this out. So h of x is this, okay? And h prime of x is this. That's interesting. Because really, I would think that this is what should happen. If you do the product rule correctly, right? The product rule is done correctly. Let me update this here. F prime of x times g of x plus f of x times g prime of x. Well, here's the thing. They tell us that h prime is just this, right? So apparently this is kept, and that's gone. So what this tells me, this is the conceptual and abstract part of this, is that f prime equals 0. Because f is a constant. That's what you have to deduce from that. And that's going to take a little time to think through. Because really h prime should be what I just wrote here in red. That's what really should be using the product rule correctly. But the fact they say it's just f times g prime, this is telling me that, yeah, f prime is probably 0 then. And if f prime is 0, that means that f was a constant. That's how that happened. And f of 0, of course, is 1. So the answer is just E. Because just equals 1. Because they gave us one example of an output for f of x. When I plugged in 0 for x, the output was 1. So it looks like whatever you plug in for f is always going to be 1. So that's what's going on there. Again, it's a little strange, but kind of a trick question. So that's how we would think that one through. And again, it's just going to take some practice. You have all the answers, by the way. They're all up in Schoology for everything. 9 is going to be a problem that might be good for me to talk about, and then I'll have you guys then try 10 and 11 and 12. I'll have you guys try those 3, and then we'll keep moving. But let me talk about 9, because 9 I haven't covered yet with Will and Julia. So Will and Julia, basically you guys will still need to learn chapter 7 stuff, which is 3 sections, 7.1, 7.2, and 7.4. But those are the things I'll give you guys stuff to do over the weekend to watch. And then we're going to do a review of volume, or we're going to talk about that 8.3. A1, this is like section 8.1 we're talking about here. A2 is easy. That's an easy topic. So let's look at this one. The flow of oil in barrels per hour through a pipeline July 9th is given by the graph shown above. Awesome. Of the following, which best approximates the total number of barrels of oil that passed through the pipeline that day? Okay, so this is a rate. Okay, so this is what they're giving us. It's a rate because barrels per hour. And they talk about the flow of oil. So it's how much it's flowing over time, and doing this with time, right? So think of NFT as a number of barrels. So N prime of T is a rate. And the graph here is for N. This is really what's going on here. So what we want to do, in essence, is integrate N prime of T. And we do it for the whole day, so from 0 to 24 hours. And this is part of FTC, because you're doing an integral of a derivative. They actually knock each other out. So why don't you just become just this then? That's really what's going on here. So really, I'm just finding the area, because that's what an integral is in the first place. So if this is an n prime graph, I want to integrate this to get the number of barrels of oil that's passed through, yeah, I just need to find the area here. And you actually have like this rectangle and then kind of like this triangle right here. That's going to be 24 times 100, or 2400, base times height. That's going to be 1/2 times base times height. Your base is 12. Your height is 100. So that's 600. Add up, you get 3000, and that's why it's D. You guys will need some practice with this. I think, even you too, Connor, I think it would be good to kind of watch my videos on 8.1 because we did this right near the end of session number 2. It's an application of 6.4 of the fundamental theorem of calculus. And that's, and so these word problems, they seem a little confusing at first, but once you see enough of them, you'll be fine. In fact, actually, I could probably assign some stuff to Albert IO on that. So let me make some notes here. 5-6, Will and Julia, Tori, 717274, mock, AP exam. Yeah, cool. No skipping around. All right, so now here's what I have you guys do. I think it would be a good time to do a little practice. Go ahead and give these 3 a shot. That's kind of a key phrase right there. Here's 11. And you're doing the integral of a second derivative. And you're told f is linear. So hopefully that gives you a little bit of a clue there as to what's going on. And 12 is involving a limit. So go and mull over those for a few minutes. If you're stuck, just put some in the chat. Let me know. I'll give you a little push. And we'll try those 3 right now. Okay, we'll talk about this in about 1 minute. Then maybe we'll move on to calculator type questions. Okay. So it's takes rate change. All this means is just take the derivative and it's a product rule. Sorry, quotient rule. So you do the derivative of the top, just 2x, and leave the bottom alone. You switch it up, there's a minus, leave the top alone, and do the derivative of the bottom, which is 1. Bottom x minus 1 squared. So you get 2x squared minus 2x, oops, minus 2x. There's a times there, sorry. 2x squared minus 2x, and minus x squared plus 2, yeah, plus 2. So you have x squared up top, minus 2x plus 2. And if you were to plug in 2, you get 4 minus 4 plus 2 up top. Down below, you have 1, 2. So the answer is D. That's all.
Mr. Mashi, could you cancel out the x minus 1s?
No, because there's a minus in between. That'd be just being the order of operations. It's kind of like telling me then, well, if I have 4 plus 5 over 4, can I cross out the 4s? No, you can't, right?
Okay, then I got really lucky because I did that and I still.
Oh, let's find out. Okay, so you did this then?
Yeah.
Interesting. Yeah, you got really, yeah, because you got really lucky. Yes, you did.
Sounds good.
All right. Well, sometimes it's better to be lucky than know what to do. I'm just kidding. This one here is going to be f prime b minus f prime a. Because what you're doing is you're doing the antiderivative of the derivative. And so it just goes, it basically, the derivative loses the value of, well, instead of going from second, it goes to the first derivative. Just think of it that way. Because in order to go back to this, I'd have to do a derivative of this to get back to that. So that's what's happening there. Now you're told it's a linear function. So like, for example, like y equals 2x plus 4 could be a possibility, right? So the derivative, of course, is just a constant. So the derivative, regardless of whether you're playing B or A, is going to be a constant. So these are actually going to be identical to each other. So that's why the answer is A. So kind of like a trick question, kind of like what we saw for number 8 here. That's going to be A for number 11. Because again, yes, if you do the FTC correctly, do the integral of f double prime becomes f prime minus f prime b minus f prime a, plug in the limits of integration. And then you're told it's a linear function, like this is a possibility. So derivative that's going to be a constant. So f prime b is going to equal f prime a. It doesn't matter what you plug into the derivative. If your original function is linear, your derivative is a constant. Who cares what you plug in? It's always going to be the same. So that's why it's A, that one.
And Mr. Mashi, so f double prime of a linear function is also 0, right?
Yeah.
Okay.
So actually, you are integrating 0, so it's going to be 0 anyway. So yeah.
Right. And then
no way to think of it too. Sure.
So no, I was just like, I still did it that way. But I'm just realizing now that I could have just done that.
Yeah.
But oh shoot, what was I going to ask about that? I think I've sort of forgot my question, but I think it was something along the lines of if f double prime of 0, f double prime of x is 0, what would be like f double prime of like b minus a, I guess. So if you did the integral of f triple prime, like what is f triple prime?
0 still.
It's 0.
Because f double prime is 0.
Non-existent thing.
Yeah.
It's just 0.
Mm-hmm.
Okay, cool. Yeah. Got it.
Now here we're gonna have to know, this goes back all the way to September or August actually. Knowing left and right hand limits, you need left hand limit to equal the right hand limit for this limit to exist. So, you know, I'll first do the left hand limit. Notation wise looks like this. Which really just plug in 2 into ln x. So boom, there we go. The right hand limit as x approaches 2 to the right. That's going to be 2 squared times natural log 2, which is 4 times natural log 2. Clearly, those are totally different things. Our left hand limit does not equal our right hand limit. That's why it's non-existent. Of course, if they were the same thing, like let's say they're both ln2, then great, then you say the answer is A. The quick and easy way is just plug 2 into both expressions, because 2 is the boundary for both of those, for the conditions for the piecewise function. So yeah, and they're totally different. So that's what's going on there, that one. Okay, so I think now is a good time to kind of move on to maybe some calculator type questions, because that's always a good thing to do. So you want to open the file that says multiple choice calculator aloud. And we'll start with 1998 as well. Now here you actually get 3 minutes per question. You actually do need to use your graph. Now, yes, Desmos could be good if there's things that just requires a graphing, doesn't require like the n deriv or fn, features in the calculator. And remember to access those features, n deriv, which is numerical derivative, or fnit, which is numerical integration. You gotta go alpha in your calculator, and then a window. I'm sure there's some online applications that you could probably do that, but who knows? I don't know how this is going to go, the digital AP calculus, if they're going to disable some things on your browser. I don't know. And plus Desmos, even though you could use Desmos for things that just require simple graphing in this part of the AP exam, that might be disabled too. So just know to use your calculator well. But some of these don't require a calculator at all. Like they're just conceptual. They like throwing conceptual questions in here, which is definitely number 76. But 77, looking at the choices, we're definitely going to use a calculator for that one. Let's talk about 76, 77. And yeah, maybe I'll do those on the next page as well. And then maybe I'll have you guys try. I'm just kind of skipping around a little bit, see what makes sense. Well, I also realized there's some concepts that Will and Julie have not seen yet. So let's just start with these two here, and then we'll see where this takes us. So the graph of the function f shown above, which the following statements about f is false. Okay. So well, f is not continuous. That's pretty obvious. So I definitely think that one is false. F is relative maximum. Yeah, I would say so, because it definitely seems like a high point. X is in the domain, that's for sure true. The left-hand limit equals the right-hand limit. That's what this is, the right-hand limit. Yeah, totally, that's true. Even though it's not continuous if x equals a, that's true. And the limit does exist because of choice D. So those are out. And B is just, it's kind of a weird one, because usually when we talk about relative extrema, it's usually when the derivative changes sign. But for discontinuities, it could be a relative max, because it is the highest point in that neighborhood. kind of a strange choice, but anyway, but definitely it's not continuous. So that definitely is false. Now this one's going to involve some calculator work. You're given two functions of what values of x, f, and g have parallel tangent lines. Okay, so what you want to do is find this derivative, which actually you could do by hand. Find this derivative, which you can do by hand as well. Actually, I'll just tell you right now, it's 18x squared. This one is going to involve a chain rule. So it's e to whatever is e to whatever, but then times the derivative of the input, which is, of course, 2. So 6e2x. So you're going to want to graph these. Okay, you're going to want to graph these here. So 6e2x. And really what you're looking for is where they intersect, because you want these equal each other. Because if you want to have parallel tangent lines, it means they have to have the same slope. And these are the derivatives are the slopes. So you want f prime to equal g prime. You want that. And then this is where we have to use a calculator. You could probably divide by 6 to make your life a little easier. 3x squared looks like this. E to the 2x probably looks like that. You gotta figure out where they intersect. So this is where you're gonna have to graph these in the calculator and find the point of intersection. And again, we'll let y1 be e2x. Let's let y2 be 3x squared. But conceptually, you had to realize that derivatives had to be the same. And then once you find those derivatives, them equal to each other. And then finding derivatives by hand are easy. So go ahead and do that right now. Just want to make sure you guys are comfortable finding points of intersection in the calculator. You can go and put in the chat as to what you got, and we'll want to make sure we all get the same thing. Okay. Actually, let me do it on my other device here. Desmos. E raised to the 2x. Y equals 3x squared. Yep, -0.391. Good work, Connor. Thank you for sharing that. So let's see. Okay. Let's just skip around a little bit. Let's do maybe more calculator-specific questions. Like number 80 is a good calculator-specific question. Definitely, how many critical values of f does this have on the open interval from 0 to 10? So a critical value is basically when f prime equals 0 or f prime does not exist. This is on the open interval from 0 to 10. So what you want to do is simply let y1 equal all that junk. And the way you probably want to type it in the calculator is probably like this. Parentheses, cos x squared slash x minus 0.2. It will follow the order of operations, so we'll do it correctly. And then what you're going to want to do is find the x-intercepts. Or not find, but count the number of x-intercepts. The only way this will be undefined for this f prime function is when x is 0, but 0 is not included. And oh, by the way, you're probably going to want to go to Window, make your x-min make your x-min 0, make your x-max 10. And then you want to count the number of x-intercepts. So go and try that and tell me what you guys got. I'll do here on Desmos also. Again, you guys should use your calculator. I'm just cheating because I'm lazy. So how many x-intercepts are you guys getting? Oh, you have to be in radian mode too, by the way. You'll never ever be degree mode for this test. So again, just graphing that, just count the number of x-intercepts. Yeah, it's 3. Yeah, if you can't see it well, maybe make the y window tighter. Maybe let y min be -1 and y max be +1. That's a little trick you can do to make it just a little tighter so you can see what's going on. Or you can hit the trace button and kind of see, okay, if you see a sign change in y. Yeah, definitely it's 3 times. So, let's do a trapezoidal approximation because you guys kind of need to know how that looks. And then let me do kind of A7 and 88. Those are also good calculator type problems. And 92 might be kind of good to kind of teach you guys about area. I just gonna do have to end the call by 10:30. I know it says it's gonna go till 11, but I have to do a COVID test because I have to be on campus on June 1st, and I'm gonna have no chance to do it tomorrow because of honors convocation. That's just gonna take a lot of my time. And then Friday we got some family stuff going on, and I have to get it done for the Memorial Day weekend. So unfortunately, I do have to bounce out by 10:30 to do a COVID test. Hopefully it's the last time I ever have to do one. So, because I don't think they'll make us do them next year, or whatever college you guys are going to. Hopefully, just show you're vaccinated, you're good. So let's take a look at 87. Then we'll do 88, and then 92. Then we can end our call for that. Oh, and I also want to do. Hold hold on. Oh, sorry. Let's do 85 first. I want to do trapezoidal. Let's do 85 first, then 87, then 88, and then 92. That's where we'll stop. Okay. So for 85, now you guys are familiar with Riemann sums. Like for example, if I want to do like a left Riemann sum, you take the width of this interval, just 5 minus 2, times this y coordinate, which is 10. And then you kind of rinse and repeat for the rest of the intervals, right? Or a right Riemann sum, you do the same thing, but you do that corner. So 5 minus 2 times 30 and rinse and repeat. A trapezoidal sum, first of all, it helps to know the area of a trapezoid, which is just this, which you might remember from geometry. Graphically speaking, let's say I got a very funky curve. So I'll give you guys kind of a crash course on the trapezoidal approximation. I'll still have you guys watch the video, but it's really easy. It's not that hard. So say this is A, say this is B. And let's say I do these subintervals, okay? All right, I just do these subintervals. So this could be like my first trapezoid. This could be like another trapezoid. This could be like another trapezoid. This could be yet another trapezoid. This could be yet another trapezoid. You see the trapezoidal approximation actually does a better job of approximating than the rectangles, because the rectangles sometimes have too much under, too much over coverage or approximations. Well, what you could do is think of this as B1, and think of this as B2, and think of this as your height. And kind of like tilt your head a little bit. So you have this trapezoid that looks like this, right? Which you can actually rotate like this. B1, B2, and height. So height's right here now. That's B2, and that's B1. So the delta X is actually the height. And the B1 and B2s are actually the Y coordinates that you get from the table. And that would be your first trapezoid. And then you kind of repeat over and over again. So for this particular table, what I would do is I find the width, that's going to be my delta X, or my height, and then 10 plus 30. That's like my B1 plus B2, which is really F of A plus F of whatever, right? And so that's going to be the first entry for the trapezoidal approximation. Then you have to do it again. 7 minus 5. So you can use a calculator if you want, I suppose, but to do all the arithmetic. But you do, the setup, you're going to have to be able to kind of figure out. That's what you do tables, because there's nothing you can input in your calculator. You actually have to do this by brute force. 8 minus 7, 40 plus 20. There are some programs in the calculator, if they give you a function that does a trapezoidal approximation where you specify the intervals, blah, blah, blah. But, and plus they space these out not unequally for the intervals, like the first width of the first interval is 3, the width of the second interval is 2, the width of the last interval is 1. And then you work all that out. So I just gave you guys a crash course in trapezoidal approximation. So in this case, yeah, just work it out. That's just going to be what? 3 times 40, 2 times 70, and 1 times 60. So that's 120 plus 140 plus 60, you get 320. Oh, but I goofed though. There's also a 1/2 on the outside too, because that's part of the formula. It's 1/2 B1. Yikes! I can't believe I forgot to do that. I would totally pick the wrong answer to put 320. So you got to multiply by 1/2, so it's 160. That's why it's C. So that's trapezoidal approximation. And we're going from 2 to 8, right? So you need to integrate, to approximate the integral. 86 involves volume. I don't think we're ready to do that yet. So let's look at 87, 88 here. For 87, they want the equation of the tangent line. Well, f prime, of course, is 4x cubed plus 4x, right? And f prime is 1. So I can actually solve for x, because yes, I know 1's going to be my slope. And yes, I know the equation point slope form. I know this. Plug in 1 for the slope, easy peasy. But I don't know what x value or y coordinates this happens at. Where's the point of tangency? So I actually have to solve for this. And I'm going to have to actually use my calculator to do this because it's not factorable. So you could do a couple ways. Move the 1 over from right to left and find the x-intercepts, or you can find where they intersect. Let y1 be 1, let y2 be 4x cubed plus 4x, and find the x where they intersect. And then plug that in to find f of whatever. But let's figure out where they intersect. So y equals 1 looks like this. 4x cubed plus 4x. I don't know, it's kind of like this, I think. So let's work this out, give it a sec here. Good sec here. Desmos. Y equals 1, y equals 4x cubed plus 4x. Yeah, it looks like they intersect at 0.237. And yeah, I got to now do f of 0.237. And if I were to plug this into my original function, I'm going to use my graphing calculator. So 0.237 raised to the 4 power plus 2 times 0.237 squared. I get 0.115. So that goes over here. Move things around. And you should get negative 0.1222. So it should be D. Okay, we'll do a couple more. We'll wrap up our call. 88. Let f of x be the antiderivative of this. If f only equals 0, find f. So this is a fundamental theorem of calculus problem. So what you're going to do, you integrate this from 1 to 9. And so it's just going to be capital F of 9 minus capital F of 1. Because you told f of x is the antiderivative of this. Don't actually do the antiderivative by hand, because this would be insane. I think you could, there's some techniques you could do, but I wouldn't recommend it. It's just going to be too much work. But yeah, then I would just use my calculator to work out this part. So you need to try and find capital F of 9. Capital F of 1, of course, is 0. So that makes our life a little easy. And then this is going to be all in the calculator. So I go alpha window, pick option 4, which is f and int, go from 1 to 9 for your limits of integration. Because again, you're doing the, they told you that capital Fx is the antiderivative, right? So that I want to do the definite integral because it's going to equal f9 minus f1 as part of FTC part 2. And then I do, let's see here, natural log of x cubed divided by x. So I get 5.827 And that's why the answer is C. So there you go for that one. Now, this is actually kind of good practice, which is something that Julian will haven't seen yet. There's something called U sub, or antiderivatives, or anti-differentiation by substitution. You could technically have done this. It would have taken longer, but you're integrating natural log of x cubed. I'm going to do times 1 over x, and then dx. And we do is you let u equal one of these expressions, the letter u, like ln x. I know the derivative of ln x is 1 over x. Or du equals 1 over x times dx. Or dx is x times du. So that's what I'm going to do here. Ln x, so that's u cubed times 1 over x, and then dx is x du. And the x's cancel. So that's something you could do, perhaps. It's called a U sub, which I'll have to have Julian will watch videos on that over the weekend. It integrates u4 to the 4. And the limits of integration have to change also. Originally, they were 1 and 9. But because I let u equal natural log of x, when x is 1, natural log of 1 is 0. And if I plug in 9, well, just natural log of 9. So that's what you're plugging in. And if you were to actually plug a natural log of 9 and raise that to the 4 power and divide by 4, you would get 5.827. But much easier just to kind of just integrate that straight up in your calculator from 1 to 9. Way more effective. Okay, the last one, let's do 92, and then we'll stop there. So for this one, they say that the area in the curve y equals cos x from x equals k to x to the power 2 is 0.1. Okay, now when you do here, so cos x looks like this. And here's pi over 2. That's an x-intercept for cosine. And x equals k, I don't know what x equals k is exactly, but it's going to be like that. And the area is 0.1. Okay, we know this. So it means that if I integrate from k to pi over 2 of cosine x dx, it's supposed to equal 0.1. Well, the antiderivative of cosine I know is negative sine. So negative sine x so it's negative sine sine pi over 2 I know is 1, so that's negative 1 plus sine k. So sine k equals, oh, that's a problem. Can't equal, that'd be undefined. Shoot, what did I do wrong? You can't do inverse sine 1.1. What did I do wrong here? I mean, I suppose I could work backwards and test these with choice sets too and use my calculator, but oh, it's just sine. I'm tripping. The derivative cosine is negative sine. Sorry, the antiderivative cosine is just sine because the derivative sine is cosine. I'm tripping. There we go. So I get negative 0.9. Oof, okay, I was getting a little nervous there. And then you do inverse sine of negative 0.9. They get negative 1.11 or negative 1.20. The problem is that that's in the fourth quadrant. We clearly want this in Q1. So you just have to find the equivalent angle in Q1, which would be positive 1.120. And that's what the answer is going to be D. And actually, if you were to integrate that, if you had alpha window, option for 1.120, 0.5 pi of cosine x, yeah, you do get something very close to 0.1. So you have to be a little nifty with the calculator sometimes. It's kind of a skill that you want to be good at. Okay, so we're going to stop there. That gives you guys a little review. So I think what I'm going to suggest for you guys to do, I'll send you guys individuals. I'll do it by tonight when I get a chance, is to watch some videos of what remaining topics I know that you guys need. In the case of Julia and Will, will be 717274. In case of Connor, will be 545556. And then we'll do this again on Monday if you guys are available. I'll record if you're not. I'll also send you guys a mock AP exam. Probably I'll do it on Albert IO as a digital exam so you guys can practice and can see how you're doing. And also I think you guys probably need a little extra work with integrals net change. So I'll send you guys some work on that too. Probably do that through Albert IO as well. So I'll individually assign it. And that way I can see your work. I can see your progress as you do it real time. And then, yeah, we'll have 3 meetings next week. They'll be from 12 to 2 this time. Monday, Wednesday, Friday. Even Memorial Day, I'm meeting that day with students. And then the following week will be 12 to 2 on June 6th, June 7th, which is the Monday before the AP. That'll be just like one final review session. So we still have 4 more meetings like this. Sorry I can't do a full 2 hours today. Plus I don't know if full 2 hours might be a little hard. But I think next week we'll try to aim to do full 2 hours. We'll be a little more interactive with more people. There'll be more practice problems you guys do. I think you guys are still kind of coming up for air after all the graduate festivities, so it might be a little shock to the system that you're doing some work even though you are technically done with high school. Okay, so we're going to stop there. I'll stop the recording.